Hello students, how are you all? I hope that you all are good. As we know, the series of motion in a straight line is going on and we are successfully finished the 6 lectures, right? In our previous lecture that we have discussed about equations of motion. So what are the equations of motion we have and the proofs of equations of motion by using the integration method, and at the end of the session we have discussed some example problems, right? In a today's lecture that we are going to discuss about equations of motion in case of a vertically projected body and a freely falling body, and the graphs for displacement versus time and velocity versus time and the acceleration versus time in these two cases. Okay, and also at the end of the session that we are going to discuss some of the previous year questions of JEE mains and the NEET. Okay, so my name is Rakesh Kanganti. Welcome to our beautiful physics channel, Rakesh sir Physics. Shall we start the session? Right. So what is the chapter going on? Motion in a straight line. And what is the class number? This is a class number 07. Right? Right. So before going to start the session, we have some small concept, that is motion under gravity. Motion under gravity. This is also called as a free fall. This is also called as free fall. Okay. Right. Have a look. What is the meaning of motion under gravity or free fall? Right. Have a look. The definition. The acceleration. The acceleration produced in a body by the force of gravity. By the force of gravity is called acceleration due to gravity. What is the meaning of acceleration due to gravity? If the acceleration produced in a body by the force of gravity, then it is called what? Acceleration due to gravity. Okay, and it is denoted by small g. So acceleration due to gravity can be denoted by the letter small g. Okay, and its value and its average value and its average value on the surface of the earth, the surface of the earth, not a surface is equals to 9.8 meter per second square. So what is the value of small g on the surface of the earth? It's an average value. How much? 9.8 meter per second square. So why we are taking a average value of g, acceleration due to gravity? Because the value of g is changes with respect to the place on the surface of the earth. That means if you went to the poles, okay, if you reach to the poles, so at the poles the value of acceleration due to gravity is small. This that is nearly equals to 9.7 meter per second square, 9.725, like that. If you comes to equator, at the equator, the value of acceleration due to gravity is more, which is equals to 9.872 something. Okay, so on an average, if we take off, we will get the value of g is equals to 9.8 meter per second square. This is the average value of g. Okay, right. In the absence of air, in the absence of air, all the objects all the objects which are moving towards moving towards the surface of the earth having same acceleration, having nearly, okay, nearly same acceleration irrespective of irrespective of their size and the weight, their size and the weight. So in the absence of air, so whatever the objects are moving towards the ground, all are having nearly same acceleration. All are having nearly same acceleration, irrespective of their size and weight. So whatever the objects which are falling towards the ground, which are traveling towards the ground, so in the absence of air, that means in a free space. In the absence of air means in a free space. All are having the same acceleration. All are having the same acceleration. Okay. So have a look. If the acceleration of an object, let us say small a, is equals to acceleration due to gravity, that is what small g. Okay, so if the acceleration of an object small a, which is equals to acceleration due to gravity g, then the object is said to be freely falling body. Then the object is said to be what? Freely falling body. It can also treated as motion under gravity. It can also treated as motion under gravity. So what is the meaning of freely falling body or motion under gravity? If the acceleration of an object which is equals to acceleration due to gravity, that means how much? G is equals to 9.8 meter per second square. So if the acceleration of the object is equals to 9.8 meter per second square, then the object is said to be what? Freely falling body, and the motion of that object is called what? Motion under gravity. Is it clear? It's a small concept. Write down. So pause the video and write the notes. 3, 2, 1, go. So let us discuss about equations of motion of a body in case of vertical projection and freely falling condition. Okay. So for my convenience, I'm just divided this board into two equal parts, right? So this side, I'm going to discuss about equations of motion, equations of motion in case of vertically vertically projected body, vertically projected body, right? Have a look. From the ground, I'm considering this line, horizontal line, as a ground. Okay. From this ground, I'm just projecting an object in a vertically upward direction. Okay. So here I'm taking the object and I'm projecting the object in a vertically upward direction, right? If you want to project an object in a vertically upward direction, you must give an initial velocity for that object. You must give an initial velocity for that object, then only the object moves in a upward direction. Are you getting? So if I am taking the object, if I say like this, hey object, move in a vertically upward direction, it is moving for my command? No. So when this object is moves in a upward direction, when we are give some initial velocity for this object, if we give some initial velocity, then it moves in a vertically upward direction. Are you getting? Whenever you are throw a ball in a vertically upward direction, it is moving in upward direction. After it reaches to the certain height, okay, it will be stopped for the fraction of seconds. It will be stopped for the fraction of seconds. After that, again it starts moving towards the ground. Are you getting? Right. So we are thrown an object in a vertically upward direction with the initial velocity u, and this object will reach the and this object will reach to the certain height, and it will be stopped for fraction of seconds. Okay, it will be stopped for fraction of seconds, 0.0001 second. Okay, that means its final velocity. Its final velocity is equals to how much? Zero. The final velocity of the object is zero. Right? The object is moving like this. Okay. La 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 la. Right. So we got our final velocity of the object is zero at a certain height from the ground. From the ground at a certain height, the final velocity of the object is zero. That means the height at which the final velocity of the object is zero. What I am saying? The height at which the final velocity of the object is zero from the ground. From the ground, that height can be treated as a maximum height. That height can be treated as a maximum height. So what is the meaning of maximum height? From the ground, the height at which the final velocity of the object becomes zero, that height is called what? Maximum height. Now from this diagram, it is clear that at this height from the ground, the final velocity of the object is zero. Then this height is called what? Maximum height. What is this? H maximum. Maximum height. Are you getting? Initial velocity of the object is u. Okay. Displacement. What is the meaning of displacement? The shortest distance between the initial and the final point, or the shortest distance between the initial and the final position is called what? Displacement. From this diagram, it is clear that this is the initial position of the object, and this is the final position of the object. Now what is the distance between the 2 points? That is equals to h maximum. Now the displacement of the object is equals to how much? H maximum. Displacement is equals to how much? H maximum, maximum height. Okay, so acceleration. What is the acceleration of the object in this case? Have a look. We are projected this object in a vertically upward direction with certain initial velocity u. After it reaches to the maximum height, its final velocity becomes zero. That means there exists a change in velocity. Okay, so the object is moving in this direction, okay, with some velocity, and on this object the acceleration due to gravity is acts in a downward direction. Okay, are you getting? The object is moving in a upward direction. That means the acceleration of the object is in this direction, but on every object the acceleration due to gravity is acting in a downward direction. Have a look. For the acceleration of the object, the acceleration due to gravity is in opposite direction. For acceleration due to gravity, small a is equals to minus g. Small a is equals to how much? Minus g. Where minus g represents the acceleration of the object is opposite to the acceleration due to gravity. Minus means the acceleration of the object is opposite to acceleration due to gravity. Are you getting? And just considering the time taken by the object to reach a maximum height, let us say t. Time t is equals to how much? T. So these are the required quantities. So what are these? These are the required physical quantities to solve equations of motion. Are you getting? Any doubt? Right. I am going to write the equations of motion. Okay. So what is the first equation of motion we have? The first one is V is equals to U plus AT. V is equals to U plus AT. V means what? Final velocity of the object. From this diagram, it is clear that the final velocity of the object is 0. So 0 is equals to initial velocity of the object is how much? U. Acceleration due to gravity minus g. and the time taken by the object t. Okay, I'm just bringing this u to this side and it becomes minus u is equals to minus gt. It plus u comes to this side, it becomes minus u. So minus minus get cancelled out and we got u is equals to gt. I'm just writing here only, u is equals to how much, gt. So from this condition we can write, so the time taken by the object to reach from the surface of the ground to maximum height, how much, t is equals to u by g. T is equals to what, u by g. So this time is called the time taken by the object to reach maximum height from the surface of the ground is called time of ascent. So whatever the time here we got, this time is called what, time of ascent. What is that, time of ascent. Okay, what is the meaning of time of ascent? The time taken by the object to reach maximum height from the ground, from the ground. I'm just writing this ground this side. Okay, this is what, this is ground. Okay, from the ground is called time of ascent. Okay, so ta means what, the time taken by the object to reach maximum height from the ground is called what, time of ascent. And we got the value of time of ascent is equals to how much, u by g. Just keep it aside. Okay, right. So I'm just taking the second equation of motion. What is the second equation of motion we have? S is equals to ut plus half at square. S is equals to ut plus half at square. What is displacement? Maximum height. I'm just substituting all the values. Initial velocity u. What is the time taken by the object to reach the maximum height? U by g. Minus a is equals to minus g. Are you getting? I'm just substituting the values ma. Okay, so minus half g t square. What is the value of t? U by g whole square. Are you getting? Any doubts? Okay, sir. Okay, sir. Okay, sir. U into u, u square by g minus half g u square by g square. U by g whole square means what? U square by g square. So g get cancelled out and we got h maximum is equals to u square by g minus half u square by g, u square by g, and h maximum is equals to, here we have u square by g and here we have u square by 2g, u which is equals to u square by 2g. So maximum height of the object is how much? U square by 2g. H maximum is equals to how much ma? U square by 2g. Are you getting? Any doubts? Okay, right. Very good. Right. Let us see the third one. What is the third equation of motion we have? V square minus u square is equals to 2as. V square minus u square is equals to 2as. Final velocity of the object is 0 minus initial velocity is u square, which is equals to 2. A is equals to minus g. What is s? S is nothing but what? H maximum. S is equals to what? H maximum. Have a look. This minus and this minus will be get cancelled out and we got u square is equals to 2g h maximum. So u is equals to, we can write under root 2g h maximum. U is equals to, we got how much? Under root 2gh. Are you getting? So I'm just substituted all the values of VUSAT. Okay, VUSAT. Oh, right. Note. Substitute equation 1. Okay, you just write like this. Substitute U value in a equation 1. Substitute u value in a equation number 1. So what is the equation 1 here? P is equals to u by g. P is equals to what? U by g, which is equals to, what is the value of u? Under root 2g h maximum, under root 2g h maximum divided by g, under root 2g h maximum divided by g. So we can write this equation as under root 2 into h maximum into root g divided by g can be written as root g into root g. G can be written as root g into root g, and just bring this root g from this quantity outside. So 2 into h maximum under root into root g is equals to root 2g h maximum. Are you getting? So root g get cancelled out, and finally we got under root 2 into h maximum by g. So this is also one of the time equation in case of vertically projected body in upward direction. So what is that? P is equals to under root 2h by g, or 2h maximum by g. Are you getting? Any doubts? So this is what initial velocity under root 2g h maximum. This is what time in terms of maximum height or displacement. Time in terms of displacement. This is what time in terms of initial velocity. Time in terms of initial velocity. What is this? Maximum height in terms of initial velocity. Just write all these things. Are you getting? Are you understood? Any doubt? The second part. What is the second part? Equations of motion. Equations of motion in case of freely falling body. Freely falling body. Equations of motion in case of freely falling body. Are you getting? Right. So what is the meaning of freely falling body? Already I told you at the starting of the session. What I told you? If the acceleration of the object is equals to acceleration due to gravity, then we can say that it is a freely falling body. Are you getting? Right. So here the object we have. Okay. So what I told you? In case of vertically projected body, the object after reaching to the maximum height, its final velocity becomes zero for the fraction of seconds. Okay, so this is what discussed in this case. Now after reaching to the maximum height, it is stopped for the fraction of seconds. It is clear. Okay, now from that maximum height, again the object is moving towards the ground. Again the object is moving towards the ground at the maximum height. At the maximum height, what is the initial velocity of the object? It is zero. In this case, the velocity is zero at a maximum height. With the same velocity, with the same zero velocity, the object again starts moving towards the ground. What is the velocity? That is initial velocity. What is its value? Zero. Always you should remember one thing, that is, in case of vertically projected body, the body has some initial velocity, then only it can move. In case of freely falling body, the initial velocity of the object is zero and it has some final velocity. Have a look. So now this object is started moving towards the ground, and it hits the ground, with a certain final velocity. Let us say the final velocity of the object is v, and the initial velocity of the object is how much? Zero. Are you getting? Any doubts? From what height the object is moving towards the ground? From maximum height. From maximum height, it is moving towards the ground. What is the initial position in this case? This is the initial position, and this is the final position of the object. Are you getting? So now what is the displacement of the object? The distance between initial and the final position, or the shortest distance between initial and final position, is called what? Displacement. So displacement is equals to how much? Again, h maximum. Okay. So acceleration due to gravity, A is equals to, have a look, the object is moving towards the ground with respect to the acceleration J. Also the acceleration due to gravity is acts in a downward direction. Both are in a same direction, then we can take a is equals to plus g. Okay, here acceleration of the object is in upward direction and the acceleration due to gravity is in a downward direction. Both are in opposite direction. That's why here we are taken negative sign and here we are taken positive sign, because object is moving towards the ground and acceleration due to gravity is also towards the ground. Both are at the same direction. So that's why a is equals to plus g, and time taken by the object, let us say t, to reach the ground from maximum height. Are you getting any doubts? Shall we start the equations of motion? Right. Very good. You are a good student now. You understood everything easily and quickly. Not like me. You are understood quickly. Okay. So I'm a average student in my school. Okay. Although if I studied for hours and hours, I didn't remember anything. And also, if I practice more and more, if I went to the exam, then I will forget all. Okay, but you are not like me. You are a brilliant students and a good students. Okay, right. What is the first equation of motion? V is equals to u plus at. Don't take a serious. I'm just joking. Okay, right. The final velocity of the object. V is the final velocity of the object. There exists some final velocity which is equals to u. What is the meaning of u? Initial velocity. What is the initial velocity of the object? 0. What is the acceleration due to gravity? Plus g. And the time taken by the object to reach the ground is t. And finally we got v is equals to gt. Gujarat Titans. GT means what? Gujarat Titans, right? No. Acceleration due to gravity into time. That is the equation for final velocity of the object. Are you getting? Right. And taking the second equation of motion. What is our second equation of motion? S is equals to ut plus half at square. S is equals to ut plus half at square. What is S? S is nothing but maximum height, which is equals to, this is equals to, what is u? 0. 0 into something 0 plus half. A is equals to g. What is time? T square. Okay, so we got h maximum is equals to how much? Half g t square. Half g t square. So from this condition, what is h maximum? H maximum is equals to what? U square by 2g. And let us consider this is equation number 2. From equation 2, what is h maximum? H maximum is equals to u square by 2g. H maximum is equals to what? U square by 2g. So I'm just substituting this value here. So we get u square by 2g is equals to how much? Half g t square. U square by 2g is equals to what? Half g t square. So just this 2 get cancelled out. This g to this side. Bring this g to this side. It becomes u square by g square is equals to t square. U square by g square is equals to t square. Okay. So we got t square is equals to, I'm just writing this equation as u by g whole square. T is equals to how much? U by g whole square. Again it becomes u square by g square. So square get cancelled out and we got time is equals to u by g. So time is equals to what? U by g. What is the time of ascent? U by g. Now what is this time? What is this time? Have a look. Time of ascent means what? The time taken by the object to reach the maximum height from the point of projection or from the ground is called what? Time of ascent. Now what is this time? And this time is called what? Time of descent. Time of descent, and it is denoted by TD. And it is denoted by what? TD. What is the meaning of time of descent? The time taken by the object, the time taken by the object to reach point of projection from maximum height, from h maximum, is called time of descent. Is called what? Time of descent. The time taken by the object to reach from maximum height to point of projection. That time is called what? Time of descent. Now time of descent is equals to, we got how much? U by G. Time of descent is equals to, we got how much? U by G. Are you getting any doubts? So write the notes carefully. Okay. So here itself we write. So time of descent is equals to how much? U by G. Okay. Are you getting any doubt? Right. Have a look. Right. So let us we discuss one more concept, one more term, one more definition. That is a time of flight. Time of flight. It can be denoted by TF. It can be denoted by TF. So the time of flight means the total time taken by the object to reach maximum height from the point of projection, and the time taken by the object to reach point of projection from the maximum height. That means simply the sum of time of ascent plus sum of descent is called what? Time of flight. Sum of, simply, okay. So time of flight is equals to what? Sum over time of ascent plus time of descent. Okay, is called what? Time of flight. So time of flight is equals to, what is time of ascent? U by G, plus what is time of descent? U by G. So finally we got a time of flight, U by G plus U by G. U by G plus U by G. How much? 2U by G. This is called a time of flight. This is called what? Time of flight. Are you getting any doubts? Right, very good. Right. Let us we discuss about velocity of striking. So this is what? Time of flight. The next concept is velocity of striking. Velocity of striking. What is the meaning of velocity of striking? That means we are projected an object in vertically upward direction with certain initial velocity u. Okay. So after reaching to the maximum height, its final velocity becomes 0. And again, the object is started moving under the gravity. That means the object is freely falling towards the ground with initial velocity 0, and it strikes the ground, and it strikes the ground with some final velocity. It strikes the ground with some final velocity. That final velocity is called a velocity of striking. That final velocity is called what? Velocity of striking. So this is a velocity of projection, and this is what? Velocity of striking. So in this case, okay, so what is the initial velocity of the object? U. In this case, what is the acceleration due to gravity? Minus G. What is the final velocity of the object? V is equals to velocity of striking. What is the time taken by the object to strike the ground? Okay, so this is time of ascent and this is time of descent. The total time taken by the object to hit the ground after the projection. How much? Time of flight. How much time it is taken? Time of flight. That is how much? 2u by g. So I'm just taking the first equation of motion, that is equals to u plus at. V is equals to u plus at. Are you able to see the board? Right. So just substitute all these things. So what is V? V is nothing but velocity of striking, which is equals to, what is u? U is nothing but u only, plus what is a? Minus g. And what is the time of flight? Time is nothing but time of flight, which is equals to 2u by g. So g get cancelled out. So velocity of striking is equals to u minus 2u. So we got velocity of striking is equals to how much? 2u, sorry, u minus 2u. What is the value of u minus 2u? That means velocity of striking is equals to minus u. Velocity of striking is equals to how much? Minus u. Have a look. गिर गया. Okay, आप गिर गया. Right. So velocity of striking can be defined as, velocity of striking is nothing but what? Which is equals to minus u. Velocity of striking is equals to velocity of projection, but which is opposite to initial velocity of the object, which is opposite to initial velocity. Have a look. Have a look. This is the initial velocity of the object with this much of velocity we are projected, okay, from the ground. Now the object is moving towards the ground and it is hits the ground with a velocity of striking. What is its value? U. Its value also U. But have a look. U, 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 U. How they are? They are opposite to each other. Now this velocity of striking is equals to minus U. Here minus sign shows velocity of striking is opposite to, minus means opposite to velocity of projection. Velocity of projection. Are you getting any doubts? Right. Very good. So pause the video and write the notes. This is about what? Equations of motion in case of vertically projected body and the freely falling body. So if you take a second equation of motion, okay, so if you take second equation of motion, s is equals to ut plus half at square, okay. So what is s? S is nothing but what? H maximum. Initial velocity of the object is 0 plus half a. What is t? T is nothing but time of descent, u square by g square. Here a is nothing but g, so g get cancelled out and h maximum is equals to, again we got how much? U square by 2g. Okay, the same thing will be repeated. Okay, u square by 2g, u square by 2g. So that's why here I'm substituted directly. Okay, are you getting any doubt? Okay, so pause the video and write the notes. So complete concept in a single board. Okay, so pause the video and write the notes clearly and neatly. So 3, 2, 1. Right. So let us we discuss graphs of equations of motion in case of vertically projected body and the freely falling body. Have a look. Graphs of equations of motion in case of vertically projected body and freely falling body. Okay, right. Have a look. La 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 la. Right? Okay, have a look. In case of upward projected body, so what is the time of ascent? U by g. Okay, what is its maximum height? U square by 2g. Okay, maximum height is equals to what? U square by 2g. And time in terms of height, we got t is equals to under root 2h by g, 2h maximum by g. And also we got u is equals to under root 2g h maximum. U is equals to under root 2g h maximum. Okay, right. In case of a freely falling body, in case of freely falling body, so its final velocity is v, and the time of descent is equals to, again we got a u by g, and the same displacement value is same. That means h maximum is equals to u square by 2g. Okay, h maximum is equals to u square by 2g. So velocity of striking is equals to minus u. Velocity of striking is equals to how much? Minus u. Again, final velocity v is equals to gt we go. Okay, so what is the meaning? What is the time of flight we got? Time of flight is equals to 2u by g. So the total time taken by the object to reach maximum height from the ground and towards the ground from maximum height. The total time, the sum over time of ascent plus time of descent is called what? Time of flight. So this is these are the equations we got in these two cases: vertically projected upward and a freely falling body. Are you getting? Right. I'm just going to draw the graphs for vertically projected body. Vertically projected body or object, whatever it is. Okay, both are same. Right. So I'm just going to draw the graphs for displacement versus time. Okay, this is the first graph, and the second graph is for velocity versus time. Velocity versus time, and the third graph for acceleration versus time. Acceleration versus time. So this is what third graph. Okay, right. Let us consider this is ground. We are projected this object in a vertically upward direction. Now the object is moving like this. That means, have a look. The displacement of the object is increases. The displacement of the object is increases. So initially the displacement of the object is zero because it is on the surface of the earth. And with respect to the time, the displacement will be increases. That means the displacement of the object is increases like this. Okay, so after it reaches to the maximum height, at what time it reaches to the maximum height? That is time of ascent, u by g. So at this time this object will be reached to the maximum height. After it reaches to the maximum height, again it is moving towards the ground. That means it is freely falling object. So whenever it is moving towards the ground from maximum height, its displacement will be decreases. Its displacement will be decreases. Have a look. After reaching to the maximum height, again it is moving towards the ground and its displacement is decreases, 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 decreases and zero. That means from where it is started, there it is reached. So at what time it reaches to the ground? Again, time of flight, tf is equals to 2u by g. So at this time, again this object is reached to the ground and at this time the displacement of the object is zero. Have a look. The graph of displacement versus time is a parabola. Have a look. We got parabola. Why we got parabola? So here, displacement versus time. Have a look. T is equals to under root h maximum. That means time is proportional to root h or displacement. H is nothing but what? Displacement. If you take a y versus x graph, that means y is proportional to root x. Y is proportional to root x graph. So this graph is a parabola. This graph is a parabola. That's why we got the graph for displacement versus time like this. Are you getting? Actually, we get this graph like this. Okay. Are you getting, ma? So why we got like this? Because t is proportional to root h. So y proportional to root x graph is a parabola. So that's why we got the graph like this. Are you getting? Any doubts? Right. So let us come to second graph. Right. So let us we discuss about our velocity versus time graph. Okay. So in case of a vertically projected body, we are projected an object with a certain initial velocity. That means at a time t is equals to 0, the object has some initial velocity, that is how much? U. And whenever the object is moving away from the ground, its velocity becomes decreases. Okay, decreases, 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 decreases. And whenever the object reaches to the maximum height, its final velocity becomes 0 and the time taken by the object is given by ta is equals to u by g. Okay, now the object is at a maximum height and its final velocity becomes 0. So after that, again the object is moving towards the ground and it hits the ground with a negative of initial velocity, velocity of striking, initial velocity. Okay, so it hits the ground with a velocity of striking, that is how much? Minus u. That is how much? Minus u. That means again the object will be moved towards the ground and hits the ground with a negative velocity and hits the ground with a negative velocity. Have a look. Minus u. This is u and this is minus u. Okay, so at what time it hits the ground? At a time of flight, that is equals to 2u by g. Are you getting? So this is the graph of velocity versus time. Right. If you comes to acceleration versus time, have a look. In case of vertically projected body, the direction of acceleration of the object is in upward direction and its acceleration due to gravity. Okay, acceleration due to gravity on the object is always acts in a downward direction and both are opposite to each other. Have a look. This is the direction of acceleration of the object and this is the direction of acceleration due to gravity. So both are in an opposite direction. Then A is equals to how much? Minus G. So this is a simply the graph of acceleration versus time. Are you getting? Any doubts? Right. So these are the graphs in case of vertically projected body. Okay. Right. If it comes to freely falling body. Okay. Have a look. Right. So if it comes to freely falling body, freely falling body. Okay, right. So first one, velocity versus time, displacement versus time. So the second one is velocity versus time, and the third one is acceleration versus time. Right. Now the object is moving from maximum height to the ground, maximum height to the ground. And already I told you that the graph of displacement versus time is what? Parabola. The graph of displacement versus time is what? Parabola. Now the object is at a maximum height. Initially the object is at a maximum height and it is moving towards the ground, and it is moving towards the ground. Then its displacement will be decreases. So the displacement of the object will be decreases, decreases, decreases. And this is the graph of displacement versus time in case of freely falling body. Okay. So if you comes to velocity, now the object is at a maximum height. Okay. In case of freely falling body, the object is at a maximum height, and at a maximum height its velocity is 0. So in case of freely falling body, at a time t is equals to 0, the velocity of the object is 0, and it is moving towards the ground. Whenever the object is moving towards the ground, its velocity is increases gradually and it is constant. The velocity of the object is increases gradually and it is constant. Have a look. So all the points on the slope are at a same angle, constant angle. Then the slope is constant. Therefore, the velocity of the object is what? Constant. If theta constant, tan theta constant. If tan theta is constant, then the velocity of the object is constant. Are you getting? If it comes to acceleration versus time graph. So acceleration versus time. So whenever the object is moving towards the ground, then acceleration due to gravity is plus g. Okay. So the object is moving towards the ground. This is the acceleration of the object, and acceleration due to gravity on the object is also in a same direction. Therefore, we can write a is equals to plus g, and it is constant. This is what? Acceleration versus time graph. Are you getting? Any doubts? Okay. So pause the video and write the notes. 3, 2, 1, go. Right. So let us see the example problem. And this problem is asked in a IIT 2000 year. Look, a ball is dropped from a height d. A ball is dropped from a height d above the ground and hits the ground and bounces up. So they are taken one ball or an object and just they are thrown it towards the ground from the height d. Okay, right? The ball hits the ground. Okay, simply. So they are just leave an object, and the object is moving towards the ground and it hits the ground. After hitting the ground, the ball is bounces to the height d by 2. The ball is bounces to the height d by 2. So this is they are given in a question. Okay, right? So neglecting the air, they are neglected the air resistance force. Okay, which of the following graph is true in case of velocity versus height? So we have to find out which graph is true in case of velocity versus height. So velocity versus height means what? Velocity versus displacement. Height is nothing but what? Displacement. No? So the displacement traveled by the object is how much? D here. Have a look. So one thing is clear that in a previous session that we have discussed that, so v square minus u square is equals to 2as. This is what? Velocity is a function of displacement, right? So whenever the object is moving towards the ground, its initial velocity is 0. So u square is equals to how much? 0. Then v square is equals to, we got 2as, and v is proportional to root s. V is proportional to root s. I'm just considering 2a as constant. If square went to that side, it becomes root s. Just a few minutes back only, I told you that whenever you got the graph like this, v is proportional to root s, okay, y is proportional to root x, then the graph is what? Parabola. Then the path of the graph is what? Parabola. Have a look. This is parabola, this is parabola, this is straight line, and it will be cancelled out. It is not an option because whatever the graph we required, that is what? Parabola. So this is a straight line, it is cancelled out, and this is also parabola, it exists. Now in these three, one is correct option. Okay, right? Just analyze this situation. Whenever the object is moving towards the ground, its displacement is decreases. Its displacement is decreases and it is negative. So what is negative sign shows? The negative sign shows that the displacement of the object is decreases. That means initially the displacement of the object is negative. Have a look here. Initially the object is at height d and it moving towards the ground and its displacement will be decreases. This graph is exist. You observe this graph. Have a look at the height d. At the height d, the object has some velocity. The object has some velocity, but in actual case, at a height d, the velocity, initial velocity of the object is zero. But in a given graph, at a height d, the object has certain velocity. So this graph is not valid because initially we have the velocity of the object is 0, but in a graph this object at a height d has some velocity. It is wrong. Okay, these two options are cancelled out and we have two options. Have a look. Initially the object is at height d and whenever it is moving towards the ground its displacement is negative and it will be decreases. So these two are exist. Okay, over. If it comes to second case, have a look. After it hitting the ground, the ball is bounces to the height d by 2. It hits the ground. Initially the displacement of the object is negative because it is decreasing. After hitting the ground, it will be rises to the height d by 2. Will be rises to the height d by 2. That means displacement of the object is positive. In this case, the displacement d by 2 is what? Positive. If you comes to here, have a look. From here to here, distance or displacement is d or height is d. And have a look. This line, whatever the graph they are given, it is at a middle. That means it is what? D by 2 and it is positive. Have a look. It is in a positive quadrant. If you comes to here, it is also at the middle. Have a look. D by 2 and d by 2. Okay, so but after hitting the ground, the distance or displacement is what? Positive, but here we have a negative curve. So this option is cancelled out and this is our answer. So option A is the correct one. Are you getting any doubts? Right. So let us we discuss about our second question. So what they are asking, a particle is starts from rest. A particle is starts from rest and move with a constant acceleration and it is moving with a constant acceleration. So its velocity displacement curve is its velocity and displacement curve they are asking. What they are asking? The relation between velocity versus displacement. Already here we are discussed. So what is the velocity is directly proportional to root s and the graph is what? Parabola. Okay. So if you draw the graph for y versus root x, y versus root x, just you will get the graph like this. It's a parabola. So the direct option is what? This one. It is not a straight line. It is not a straight line. So these are get cancelled out. So and have a look here. The acceleration is what? Constant. This is not an option. Are you getting? So this is what? Direct option. V is directly proportional to root x. So y versus root x graph is what? Parabola. So the option is what? This one. Right. Pause the video and write the solutions. 3, 2, 1, go. Right. So have a look. The third question. So what is the question? A ball is thrown upwards. A ball is thrown upwards. Have a look. So they have taken a ball and throws in upward direction. So in case of a vertically projected body in upward direction, so the final velocity of the object is 0 and its acceleration due to gravity minus g. It has some initial velocity and the time taken to reach the maximum height t. So this is about a vertically projected object. Okay, and its height varies with the time as shown. So its height varies with the time as shown in a figure. How the height is changes with respect to the time is given in the figure. If acceleration due to gravity is 7.5 meter per second square. So acceleration due to gravity value is given how much? 7.5 meter per second square. Okay. So whenever the object is moving away from the ground, then the acceleration due to gravity is what? Negative. Okay. So then height h is. So from this graph, they are asking of this height. They are asking this height. What is this height? They are asking. Okay. Let's pause the video and try the solution. 3, 2, 1, go. All right. Have a look. If you want to find the height of this part, if you want to find the height of this part, we want to find the height of this one and height of this part. If we subtract this height from this height, then the remaining height is our answer. Are you getting? To do this, we have to know the initial velocity of the object. We have to know the initial velocity of the object. Have a look. Here time is given. Here time is given. So the displacement of the object, acceleration due to gravity is also given. So the displacement of the object can be given by ut minus half gt square. Ut minus half gt square. In case of vertically projected object, this is what displacement. It has some initial velocity. We have to find this. Okay, so already they are given the time in a graph. This is at a first second and this is at a second. Okay, so g value is also given. How much? Minus 7.5 meter per second square plus 7.5 meter per second square. Acceleration due to gravity is also given. So time also given. We have to find out what? Initial velocity of the object. We have to find what? Initial velocity of the object. Just think how to find the initial velocity of the object. Any idea? Right, have a look. Whenever the object is projected in a vertically upward direction, have a look. The displacement of the object is increases, and at a maximum height. After it reaches to the maximum height, its final velocity becomes zero. Have a look. If we draw the graph from maximum height, so this is what? Maximum height, h maximum, right? So if we draw the line from the maximum height, it lies in between 2 and 5. This line is lies in between 2 seconds and 5 seconds. Now what is the time here? Have a look. This is 2 and this is 5, and this line is exactly in between 2 and 5. Then the time average is equals to 2 plus 5 by 2, because we are taken 2 times. 2 plus 5, 7 divided by 2. 2 3s are 2 5s are, so 3.5 seconds. So here time is equals to how much? 3.5 seconds. Have a look. I am taking the first equation of motion, that is v is equals to u plus at. So at the maximum height, the final velocity of the object is equals to how much? 0. This is equals to initial velocity of the object, we don't know, and acceleration due to gravity, a is equals to minus g, and the time is equals to how much? 3.5. Just bring this minus g into 3.5 to this side, it becomes positive, which is equals to u. Now we can easily find the value of u, that is equals to, what is the value of g? 7.5 they are given, into 3.5. So 7.5 into 3.5, how much? Have a look. 25, 37, 15, 22, 5, 12, 6, 26.25. Initial velocity of the object is equals to how much? 26.25 meter per second. We got the initial velocity. Okay, so now we have to find this height, this displacement. So we can find easily. Let us say this is displacement s1. So displacement s1 is equals to, we can write ut plus half at square. What is the displacement? We don't know, we have to find. Okay, so that is s1, which is equals to u. What is the value of u? 26.25 into time at s1 is equals to how much? 1 second. At s1 t is equals to 1 second. So plus a is equals to how much? Minus g. Minus into plus, minus 1 by 2. The value of a is what? Acceleration due to gravity, they are given 7.5 into t square, time is equals to 1 at a displacement s1. Okay, so s1 is equals to 26.5 ones are 26.25 minus, have a look, here 2 is there, 2 ones are 2, 2 3s are 6, 1 remains. If we place the point, it becomes 15, 2 7s are 14, again 1 remains, 2 5s are 10. So 3.75 we got, 3.75. So 26.25 minus 3.75, how much? 26.25, 3.75, 550, 12, 75, 5, 5322. So we got S1 is equals to 22.50 meters. So we got this displacement. Okay. So next what we have to find? We have to find this displacement S2 at time T2, 2 seconds. So S2 at a T is equals to 2 seconds. Okay. So S2 is equals to again ut plus half at square. So s2 is equals to, what is the initial velocity? 26.25 into time is equals to 2 seconds, plus into minus, minus half, what is the value of g? 7.5 into t square, what is t? 2 square. So 1 2 get cancel out. So s2 is equals to 26.25, 2 are 2 5 are 10, 2 2 are 4 plus 1 5, 2 6 are 12, 2 2 are 4 plus 1 5, 2 points, 52.50 minus 7.52 are 15. So s2 is equals to, if we remove 15, 5 2 0.50, 15, so 0 5 12 5 7 4 1 3, so 37.50. So now what we have to find, this is meters, we have to find this h. So how can we find the height? So just remove s2 minus s1. Okay, just make s2 minus s1. So h is equals to what? S2 minus s1, which is equals to, what is the value of s2? 37.5 minus s1 22.50. So 37.50 minus 22.50. So 0 5 minus 5 0, 7 2 5 3 2 1. So how much? So height h is equals to 15 meters. So what is the height we got? 15 meters. Are you getting? So pause the video and write the solution. Okay. So if you have any doubt, again rewind the video and again watch it. You can understand. Right. 3 2 1 go. Right. This is the end of the today's session. We will meet on a next session, that is a motion in a straight line 08. In that session, we are discussed about equations of motion of a vertically projected body and a freely falling body. In that case, we are taken air resistance force. That means we are considering air resistance force also. Okay. So stay tuned and keep studying. All the very best. This is Rakesh Kanayanti signing off. Jai Hind.